Hello, I'm Bill McDonough, and I'm coming to you from Charlottesville, Virginia. And I've been asked to talk about what it means to think outside the box. So, first question we have to ask is, why a box? The second is, what box? Einstein famously said that if you gave him an hour to save the planet, he'd spend 59 minutes defining the problem and 1 minute resolving it. So, let's spend 59 minutes talking about what box, why a box, and then a minute resolving it. I wrote a book in 2002 with Dr. Michael Braungart, a chemist from Germany, called Cradle to Cradle, and it framed a new box. The box is, after 5,000 years of human activity, we have two metabolisms, the one of the natural world that we've talked about for ad infinitum and have experienced in our evolution, but also we can talk about a technical metabolism. So this book is designed out of plastic to be reused ad infinitum. Okay? So that's a technical nutrient. The new book we've just finished is called The Upcycle. And The Upcycle is a biological nutrient book. So this book can safely be eaten. These pages are fiber for your benefit in biology. So biological nutrients, technical nutrients, different box. But it's really not a box. It's a ad infinitum. It's endless resourcefulness. It's not life cycle assessment of a plastic, because this is not alive. This one goes into biosphere, which is alive. So let's think about humans. In the last 5,000 years, we got a new metabolism we created, technical nutrition. The camera that's filming me, the screen you're watching this on. These are technical nutrients that can go back to endless reuse in technosphere. This is nutrition for your body, for the soil, and there are things we can design like that. So if we have that, then we need reverse logistics. How do we get these things back so they go where they can be deployed properly? We need renewable energy, we need clean water, and we need social fairness. So those are the frame conditions of Cradle to Cradle. We design then by saying that everything is food, either for technology or biology or food for thought. And then we have renewable power and clean power. We have new kinds of power we're looking at that aren't even solar that are clean. It will be quite astonishing. You'll see them soon in the market. We're coming at the world with these things from this direction. And then we like to think of the water being clean, and we do that by working with careful chemistries. But the third principle, after everything is food, use clean energy, is practice social fairness. And let's all do this together and do it forever for all the children. And celebrate the abundance of the world with every child being born, instead of just looking at them and saying, welcome to a world of limits and greed. And, we don't have enough for you. You're a population problem. How horrible that would be. So let's celebrate every child born in a world of abundance. So that's what we do. Now, thinking outside the box is an important notion, I think. And the two ways I'd look at it, one is the engineering way and the other is the creative design way. One would be the Aristotelian, Lyceum, science, rationality. The other would be the Platonic, truth and beauty, art. Now, I went to Dartmouth to be a student in international relations because I had been born in Tokyo. And as a 5-year-old, I got to learn about Hiroshima. And I wondered, why would people do this? That's why I wanted to study international relations. And then, how could they do this? That's why I wanted to study physics. So when I got to Dartmouth, I took international relations to study nuclear deterrence. And I also studied physics to understand how you could physically remove a city in a few seconds from the face of the earth. And discovered at Dartmouth, looking at my fireplace in Lord Hall, burning a log, that there was entropy with the world, dispersing into chaos physically. But really negative entropy, the idea we would aggregate to our benefit, was really the log. So I realized that biology is negative entropy. It's the order out of chaos. And that the atom bomb was really equals mc squared as a math problem. It was pretty basic. And just staring at the fire and thinking about the idea of negative entropy and then looking at E equals mc squared, I realized that Einstein hadn't been dealing with biology, just M, chemistry, and E, energy, kind of physics. And so if you do the math, if C is the big number and you square it, it's almost infinity. And then if M is a positive, then E is almost infinite, and say goodbye to Hiroshima, the atom bomb. That's what I learned at Dartmouth. And I did it by just having a curiosity and having a place that allowed me to explore that. But I then realized that biology is this thing that takes carbon dioxide from the atmosphere and puts it in soil through the function of growth, and good growth. And that wouldn't it be marvelous if we could design that way? What if that was the box? Carbon from the atmosphere into soil. That's interesting. Instead of just taking ancient soil and then burning it. So, yes, a different box. Now, when you have this kind of revelation, and then you design into it, you find different things. And so engineers famously know more and more about less and less until they know everything about nothing. Architects famously know less and less about more and more until they know nothing about everything. And so people surrounded by architects and engineers know nothing about anything thanks to their contact with architects and engineers. So if we start with an engineering mind, we look at metrics, and then we can work to tactics, strategies, and goals if it's by design, human intention. And then you realize that people come up with these things like goals of 20% less carbon in the atmosphere or something like that. And this becomes less bad goals or 6 sigma mathematical perfections, but these are statistical. What we like to do is go outside that box and come at it from the point of values. Truth, beauty, Platonic, instead of just Aristotelian logic and rationality. We would like to look at truth and beauty, like Mr. Jefferson did here at the University of Virginia, with this beautiful rotunda, a sphere and a cube, imagine, where the arts and a look for truth from a beauty perspective reside, and then surrounded by the pavilions of Greco-Roman soldiers of Aristotelian rationality. And so if we put those two together, we could start with our values. So the ones I use are, how do we love all the children of all species for all time? What would that mean to a design? Well, I design buildings that are going to restore butterflies to their habitats. Why not? I can do that instead of decor and a bunch of trees I have to water in the lobby. Why can't I have butterflies hatching inside a double glass wall and let the children release them on weekends? Things like that. I guess you'd say it's out of the box. The butterflies fly out of the box and restore their ancient species to a city. So if we start with values, we can move to principles, then to goals. And so with Ford Motor Company, I built a factory there with Bill Ford where we use nature as systems to purify water instead of chemical treatment plants. And we saved Ford $35 million in capital cost day one, using nature instead of chemistry and physics. And guess what? $35 million savings day one is the equivalent of an order for $900 million worth of cars at a 4% margin. So we get to do it. So what is this out-of-the-box thing? Paul MacCready, a famous engineer, aeronautical engineer, did the first human-powered flight. He won the Kramer Prize, 100,000 pounds. And he needed the money. So he came back and said, how did he invent human-powered flight? He had 3 needs, or 3 issues. One was the need to earn the money. 2 is that he had to imagine he had never seen an airplane before. He was an aeronautical engineer. And aeronautical engineers couldn't solve it because they knew how to design a wing. They knew the materials. And it didn't work. It was too heavy for humans to power it. So he had to imagine he'd never seen an airplane. And then thirdly, he had to use any material, regardless of experience and cost, to solve the problem. He ended up using mylar and wires and things like that to make the aircraft. And he won the prize. Had to fly a 1/4 mile in a figure 8, go around a pole and come back under human power. Now, when you think also of Buzz Aldrin coming back from the moon, from Apollo 11, and they asked him, how often were you on course to the moon, Captain Aldrin? And his answer was, well, we were never really on course to the moon, but we could see it. So this idea that you would see something like the moon, and you'd move toward it, and you'd confidently know that you will do course corrections as long as you can see where you're going. Well, if we look at our culture today, and our society, we are tragically destroying the planet. And if it's our intention to destroy the earth, we're doing great, if that's the plan. But if it's not the plan, who has the plan? I don't know the other plan. So our job is to design the other plan and execute against it. So we see a delightfully diverse, safe, healthy, and just world with clean air, soil, water, power, economically, equitably, ecologically, and elegantly enjoyed. And we designed into that. That's the new plan. And when NASA asked me to work on the Mars station, as we go to the red planet, I suggested, what if we start with going back to the blue planet? Since you've figured out how to do the International Space Station and get to the moon, what if we did an Earth shot first before the Mars shot? What if you come back to Earth with what you've learned? And so we got the rocket scientists together. Because, you know, there's an old line that you don't need to be a rocket scientist to do something terrestrially, but what if you were? So we got the rocket scientists together that did the space station and said, you've solved the problem of power by inventing the photovoltaic cell. And we use nuclear power from 93 million miles away. It's 8 minutes and it's wireless. Thank you. It's at a safe distance. And we can power with that. So let's bring that back to Earth, which we have. Photovoltaics are now becoming commodity. Then water, $80,000 to get water up there per gallon. Well, they have water treatment systems, forward osmosis. We can purify the water over and over again. Let's bring that back to Earth and so on. So we designed and built with NASA the first space station on Earth. It's a building that can make 120% of the energy it requires from renewable sources. It can purify its own water. A building like a tree. How sophisticated are humans by design? It took us 5,000 years to put wheels on our luggage. We're not that smart. But a building like a tree, that's different. You see, a building that gets certified LEED and so on has a reduced energy consumption. That's great. But if all we do is reduce our carbon release, that's it? And we just show people that we're reducing our badness? Being less bad is not being good. It's being bad, just less so. These are not two numbers that are negative being multiplied into a positive. You're less bad, but you're by definition bad. So instead of saying, let's just reduce our carbon, it's like saying what you don't want. It's like jumping in a taxi and saying, I'm not going to the Hanover Inn. Is that helpful? Where are we going? So what we do is take the stuff we don't want, put it below the line and say, let's reduce that to zero. That's a good idea. So out with the bad is good as a strategy and a trajectory. But it's insufficient for what we want because zero is not a goal. It's nothing. So if you all want to be zero, well then shoot yourselves, dry up and blow away because we want you here. And you're carbon. Carbon is good if we celebrate the growth of trees and humans and soil. It's bad if it's used as a toxin in the environment. So a toxin is a material in the wrong place. We don't have an energy problem. We have a material problem in the wrong place, in the case of the atmosphere. We have carbon, a good material, in the right application, like tree, human, as a toxin, if it's in the atmosphere and that's to the oceans. So you see what's going on here? There's a box that we need to think about, which is the box of the planet we inhabit. And the great thing is, I get to work now with the government of China and with venture funds, and we're using huge funds to get organized around cradle-to-cradle technologies where cities become fertilizer factories instead of having sewage treatment plants. I was born in Japan again, and I heard the farmers collect the sewage at night. I always thought the farms and the cities were one thing. I still do. And so cities can have fertilizer factories that make 12% return while they return nutrients to the farmers, etc. The water gets purified, the businesses work, the air gets clean, the water gets clean. Of course, we can design this way. And so that really grew out of my experience at Dartmouth, which was a chance to explore broadly. And when I graduated, before I went to Yale for architecture, I was doing photography and I worked with one of our professors, and I went to Jordan with him, and I became the field representative when I graduated for the King Hussein, for the settling of the Bedouin, who had been nomads in Jordan after all these millennia. And the idea that you could think about a people settling and becoming native to place, where they had been native to a migration from Saudi Arabia up through Syria and Iraq, and now they were having to settle down, where the Palestinians had been moved to camps because of the difficulties with the Israelis. A very complicated set of international relations, but also a physical planning question. And they lived in these beautiful tents, and they were settling down. And what is a tent? And How did it work? It was amazing. The tents did 16 things at once, besides producing shade. They could be made by a factory that followed you around, the goats. They gave you milk and cheese and flesh, fur. And it was just amazing to see this place where people had inhabited it so many different ways. And to realize that an education like that you get at Dartmouth could enrich your ability to explore the issues that were being addressed. Everything from the politics to the physical reality of a glass of water. So, outside the box, what box? I don't even think about a box. The factories I'm designing now in India make food on the roof. I do electricity, heating, cooling, food, water, oxygen, jobs, all at once out of every BTU of biogas. Imagine that. Cities in China with the Internet of Things, where we'll be controlling all the equipment. We're using computers and memories so that we understand what it is we're doing. So in this world of instant communication and twittering and even new Twitter video, I've seen 6-second video. Think about it this way. You only had 6 minutes, or 6 seconds, to communicate. Perhaps the thing we might want to think about, say to each other is, in this world of short attention spans, let us hope we retain long memories. Thank you.